Hi everyone, my name is Viktor Leijon. I work in NSO engineering, and today we're going to go through an introduction to XPath, what it is, and how you can use it in NSO. So, how does XPath work with NSO? Well, the database in NSO, the CDB, is essentially an XML document. Everything you do is covered by a Yang schema, and all of the information can be seen as an XML document. So, when you use Yang, and you use XPath, you can use XPath to find information in that database. In Yang, we standardized XPath in a number of different places. We have must expressions, which express what must hold true in the database. We have when expressions that tell you when you're allowed to show a certain leaf. And we have leaf refs and identity refs. They are both limited forms of XPath used to reference nodes inside of the tree. And we use XPath in a number of different NSO extensions. We use it in templates to populate the values you want to put into your device. We use it in templates to control the control flow for if statements and for loops. We use it in kickers to react to database changes. And we use it in nano services to control the flow of your service. As you can see, XPath is a very crucial element in Yang and in NSO. And you can see here on the right-hand side an example of a Yang model and a corresponding XML payload. This Yang model is the example we're going to use running through this presentation, this world with people in it. So that's XPath and NSO. But what is XPath? XPath is the XML path language. It is used to find paths in XML documents. So if you look at the right-hand side, you have this example payload, and you have a few XPaths pointing to world, people, name equals Charlie, name. That is an XPath pointing to a certain point in the XML document. XPath is standardized by the World Wide Web Consortium, and is shared with a lot of different applications in the web sphere. It's very popular in the XML community and used for things like XSLT, the transformation tool for XML documents. In Yang, we're standardized on XPath 1.0. So if you look in the IETF standard for Yang, you'll see it specifies exactly Yang XPath 1.0. And this means that even though there are later versions of XPath defined by the World Wide Web Consortium, in NSO and in Yang, we always use XPath 1.0. So if you look around on the internet for information, it is important to remember that. So we have NSO and XPath, we have XPath. So how do you view data in NSO? Well, you have something called a display modifier. So you can do show running config, type, display, XML, or XPath. And this is very helpful for us to know what kind of data we have. And as a shortcut for finding our XPaths, we can just use this display modifier. There are a lot of other very useful pipe commands to use in NSO, and you can explore those as usual using tab expansion in NSO. So let us start out on the basics of XPath. The basic XPath describes a path similar to file system path in Linux or macOS. So /word/people/name points to a certain point in the tree. You can sometimes see it using prefixes when it's not obvious which path to use. And then you have to give an explicit prefix. You can often skip these, but there are cases we will need it. And then you can start adding predicates to filter your XPath into more specific parts. The result of these XPath evaluations are either nodes or node sets. A node is a single result, and a node set is multiple results. If we take an example XPath here, world, people, name, that will find all the people. It's not restricted to any particular person, but will find all the people and their names in the world. And every XPath expression is executed in a context. So Paths can be either relative or absolute. We looked at world people as an example. That is an absolute path. But if we have a context, in this example, assume our context is Charlie. That means that whenever we use dot, we get to Charlie's hair. Dot dot is all of Charlie, and dot dot slash age is Charlie's age. And if we do not start our path with a slash, it is relative to the current context. There is a function called current that refers to the original context, and it's a little bit of a complicated, often misunderstood function. So we'll cover that in our example later on to try and explain how that all fits together. XPaths start with a path, but you actually want to build entire expressions. So expressions can be strings, always single quote or XPath expressions. They can be numbers, integers or floating points. They can be absolute or relative paths. You can use a number of different operators for numbers or booleans. These are mostly the usual operators. It's worth observing that equality is done with a single equal sign. There is no assignment operator in XPath 1.0. Inequality is this exclamation mark equal sign. And division and modify. Division modulus is done using those infix operators. Since we use a slash for paths in XPath, we do not use slash for division to make this syntax more clean. And on top of that, there are a lot of built-in functions in XPath. And we'll get back to those. And in the appendix to this slide deck, there is a list of all the functions we support. So you can use that. And functions can work on nodes or node sets, depending on what kind of function it is. So paths, expressions, and then predicates is the final important aspect of XPaths. The predicate is any kind of Boolean expression within brackets. We have equality tests on list keys in this first example, looking exactly for the person named Charlie. And this is the most common predicate you'll see, and it is very efficient when done on a key, allowing you to find the unique elements in a list in an efficient way. But it can actually be any kind of query. So it can be, in these examples, anyone older than 18, anyone with a name that starts with a capital C, or even the more nonsensical predicate, any person where 1 is greater than 2. This is obviously no people because 1 is never greater than 2, but you can do any kind of queries. And you can start chaining the filters. So you have multiple filters. You can have anyone whose name starts with a C and who is older than 18. Or you can start using Boolean expressions saying anyone with an age greater than 18 and lower than 15. So anyone in that age range. And this will then help you filter down to the most relevant path. And it's important to remember this thing about efficiency. If you have deep paths that go into lists of lists of lists, if you do not filter out on the keys, if you do not filter out early, you will look at every sublist, and this will be very inefficient. So do filter as much as possible to get the information you want, but XPath is very powerful in its capabilities for searching. So if you start using this in NSO, the first question is, of course, how do I troubleshoot it? How do I get a deeper understanding of what XPath really does? You have a file called xpath.trace in the log directory. You might have to enable that file. That logs all of the XPaths executed in the service evaluation. So every time you use an XPath in a template, for instance, that turns up in the XPath trace. But when you're developing and when you need to debug the system, you can do something slightly better. You use commit type debug XPath. or try run pipe debug XPath and use any kind of commit parameters you want. And this pipe debug command is extremely powerful. And for XPath in particular, it gives you an immediate feedback on the XPath you're using. Other good debug commands are pipe debug service and pipe debug template, helping you understand how your service and your template respectively evaluate. So another good tool is the developer tools. So you can turn dev tools through. This opens up access to the developer tools and lets you run the XPath evaluate command in the CLI, where you can evaluate an XPath directly and see what results it gives in your current data model. Now, how do I put this all together? Well, say that you want to find the sum of the ages of every person above the average age. Well, we start by finding the average age. So we look at world people age. In our example, that is 11, 51, 21, 41. And then we use the function average. Average is a function that works on node sets. It takes this result and computes the average. So that is 31. Then we want to find all the people above the average age. So that's world people, age greater than this expression we developed in the first step. And then we add on /age to find the age of these people. We find that Chuck and Viktor are above average age. And then finally we sum it all together using the sum function. XPath eval and then the sum of that expression. And we get the number 92. And that's sort of the process for developing more complex XPath expressions. Don't try to write it all at once. Do it step by step and slowly build up your understanding of what's going on until you have an expression that works for you. And with that, I'm going to go and show you a small demo. Okay, let us take a look at how we can learn some XPath in NSO. As we said, we have a bit of an example here. This is the world with example data I'm going to be using for all the examples we're running here. As I just mentioned, we want to start by turning dev tools on, giving us this nice interactive environment for evaluating XPaths. We have this access only in configuration mode. So let us start by looking at XPath. You have a number of different options here. You can evaluate an XPath. You can evaluate an XPath as a must expression or as a when expression to see how they would behave. And you can evaluate inside of a context. As we said, the context is very important. So as you are developing your XPaths, you want to try them out in the right context. So let us try starting by evaluating a very simple XPath, all the people in the world. And if we want, we can start looking at all of the attributes of all the people in the world, their ages and all of that. We can start looking at filters, as we said. What about everyone who's older than 15? Well, that's these people, right? And what about all the people who are younger than 15? Well, that's Charlie. So what are the ages of these people? Well, the result here can be either a node or a node set. So in the case of people over 15, you have 3 results and they form a node set. And there are certain things that are relevant for a node set, right? You can start summing the ages, for instance. But when it comes to Charlie, that's a single node, right? There's only one person younger than 15. And that means you can start doing arithmetics. You can do +10, for instance, to find 21. That is not very relevant for node sets. If you try to evaluate arithmetics on a node set, what the XPath engine will do is that it will pick the first element in the list and just use that as a representative of the node set. And that's usually not what you want. So you need to separate between when you're working with nodes and node sets. Otherwise, things will get problematic. So let's look at this context thing. So you can do XPath, context, and let's try Maria as a context. So in the context of Maria, evaluate dot, right? This shows that we are in this record for Maria. And we can evaluate all the properties we have here. And as we said, here, these relevant paths are relative paths are relevant. So what we can do, let's say we want to find all the people who are younger than Maria. So we do this. We do all the people using a relative fancy path with an age lower than the current age. So what are we doing here? Well, dot refers to the current context, but we start out in the context of Maria. But as we evaluate, this first age points to the person we're looking at, but current will always point to Maria. And of course, we can just change our context. We evaluate this in the context of Viktor, you get 2 people who are younger, etc. So that's how you use context. And once we have context, we can start looking at must expressions. So let's try to use Maria again. And say instead of eval, we evaluate a must expression. Let's say that your hair must be short, or your age has to be less than 30. We don't allow long hair in people above 30. And for Maria, this works out great, but we look at someone like Viktor, right? This is false because he's both above 30 and has long hair, and it's something our expression doesn't support. And we can start using all kinds of global expressions as well, right? There are must expressions saying that there can only be one person in the world where the name starts with a capital C. And that's true. There are someone starting with a C, but there are actually 2 people. So our constraint that we're only allowed one such person is false. And that might be a constraint we want to do. We actually built in a constraint into this model. So we have constraint that only that we're not allowed to have a name that starts with a C. We try to create sorrow, right? No warnings here. We're allowed to do it. We have a change happening here where we have added a person. But if we do a commit dry run, pipe debug XPath to show off the nice XPath debugger, we get an evaluation. You can see, oh, it evaluates a must expression that looks like this. And the result is false. So I'm not allowed to commit this, right? No matter how much I try, this commit will never be allowed because it doesn't agree with the must expression. And if we take a quick look at the Yang model here, you can see that this is what it looks like. I added a must expression that said, for people, must not start with the name V. And that is what adds this constraint. Now, one final thing to look at is deref. So we have a list of nice people here, which are actually leaf refs into the main list. So if I look at nice person number 1 here, that is actually Maria. And I can use the deref function to follow that leaf ref. So if I use deref world like this, it will move me from nice people into the actual list. And I can then look at all the elements of Maria. And this, when you have leaf refs in your Yang model, is a very useful function to use. So that was all I was going to show in the demo today. Let's try to wrap this up. So with that, we're ready to wrap up this session. Hopefully you learned today that XPath is really awesome, and there are a lot of good ways to use XPath in NSO, and that you have a lot of tools available for developing and debugging them. But there's a lot more to learn. Performance varies a lot. Make sure to filter early and make sure to check your XPath if you notice a performance drop. There's a lot of very good material on the internet. Make sure that it applies to XPath 1.0. There are some more advanced concepts, in particular something called access that we haven't covered today, but there is some good material out there, and they are supported in NSO to a large extent. In the backup slides, you'll find a full function inventory, all the stuff that NSO supports, and some tips and tricks and some examples of good stuff to do. If you're interested in learning more, the material is available on GitLab together with a script that generates all these examples in the backup slides. If you're interested in more about XPath in templates, we have a link here to previous presentation on Developer Days about advanced template usage that is very useful. With that, I'm going to hand over to Marco, who's going to talk about the device automaton, a declarative approach to managing devices in NSO. Thank you very much for listening, and I hope that you enjoy the rest of Developer Days.